Many people don't realize how much evidence there is for the flood out there in geology. In fact, the secular people think there's absolutely no evidence, and it's a blind faith. But once you tune your eyes to it, and that's what this talk is going to do, tune your mind and eyes, you can see it for yourself. And when you see it for yourself, it really sinks in. So, astounding evidence. Anyway, we hear stuff like this. This is by an atheist. He challenges us. Mainstream science has no obligation whatsoever to attempt to refute flood geology. A hypothesis vaguely and confusingly worded, lacking in completeness of statement, and nearly devoid of evidence. Nearly devoid. Now, he gives us a little credit. But Davis Young, retired professor of geology at Calvin College, supposedly a Christian college, in the book of all things, the biblical flood, says there is no geological evidence to confirm the idea of a universal deluge. No evidence. Why is this happening? Well, I'll get to that when I get to the end. When I read statements like that, this is my theme verse for research. Examine everything carefully, hold fast that which is good. I'm holding fast to the Bible as God's word, but then I'm examining everything carefully. If you can't do it carefully, a lot of times you might know just enough information to get in trouble. And sometimes you don't even have to do it carefully because the evidence just, once you tune your mind to it, it stands out. First of all, we got to establish, what are we talking about, a global or a local flood? Well, like I said last night, there's a lot of big picture evidence that it's a global flood. The ark landed in the mountains. Boats that ended up in a flood go downstream, end up in a floodplain or out in the ocean. They don't go upstream up into the mountains. Anyway, I went over these last night, and I'm just going to embellish on a few of these things. Here's a quote from Genesis, that the context. The waters prevailed more and more upon the earth, so that all the high mountains everywhere under the heavens were covered. Now, doesn't that sound like a global flood, not a local flood? And here is a little cartoon, thanks to Dan Letha. Look at that beautiful rainbow. It's a promise from God that he'll never again flood the entire earth as he did in Noah's day. Well, my Christian college professor, 95+% of Christian colleges will teach evolution, millions of years, local flood. It's a sad state of affairs out there. He said that Noah's flood didn't cover the entire earth. He told you it was just a localized flood? That's what he said. So he believes that God promised to never again send a localized flood. See, the Bible, hands down, indicates it's a global flood. A lot of people question the size of the ark. Oh, it's too small. Oh, it's quite large. You can compare it to the railroad boxcars, that dinosaur there. And you don't have to fit in all the species in the world, by the way. The average kind level is probably at the family level. So you only need a matter of thousands of animals on the ark. That's it. And that kind of shocks people. And then, what did Jesus say? Okay, he did address the flood in Matthew 24:37-39. But as the days of Noah's were, so shall the coming of the Son of Man be. He's comparing his second coming to whatever flood that is, which we'll get into. He believes Noah was a real person. For as in the days that were before the flood, they were eating and drinking, marrying and giving in marriage. In other words, they weren't paying attention to the signs of the time. We need to pay attention to the signs of the time, and evolution in millions of years have greatly affected the culture, the church, and lots of individual Christians that leave the church after they leave home. And knew not until the flood came and took just a few of them away in a local flood, maybe in the Tigris-Euphrates River. No, all away, so shall also the coming of Son of Man be. But can't all mean just the local region? Oh, it can in some cases. It can. But then you got to look a little deeper. And he's comparing his second coming to this flood. And if you read Revelations 1:7, it says that when he comes back, all eyes will see him. It's going to be a global coming back. He's not going to compare a global coming back to a little local flood, is he? No, but to a global flood. So Jesus believed in a global flood, and I'm certainly going to believe it too if Jesus did. Okay, I'm going to talk about four things, and I'm going to go pretty quick. And you might only remember 5% of this in a week, but I have plenty of resources and a lot of online resources you can get free to refresh your mind. Anyway, I'm going to talk about these four evidence, hundreds of flood traditions, evidence from strata. Strata is a geological jargon for sedimentary rocks laid down by water and hardened into rock from fossils and from a field called geomorphology. Geomorphology is just simply, geo means earth, morphology means shape. It's just essentially the shape of the surface of the earth. And we have a ton of evidence for the runoff of the floodwaters on the surface of the earth that they can't explain, or they attempt to. And if you look into it, you find out it's just a wild guess. Okay, we'll get into this. Evidence from flood traditions. Well, this is, when you look at, there's hundreds of these flood legends, global flood legends all over the world. And here's a plot of them, where on the left side you see the biblical events. On the right you see the culture, the people group. And like Kevin says, I don't use the word race, I use people groups. Because it's a human race, one race. And you can see that the green square is full representation of a biblical idea, and then the red triangle, partial. By partial, sometimes when you read these legends, they're mixed up with polytheism, and it's difficult sometimes to understand exactly what they're saying, so they get partial credit sometimes. But you can see that there's a lot of similarities. Now, this is after the Tower of Babel, people spread out. And they had a remembrance of this flood still. And as they spread out, they distorted it, like the telephone game. You probably heard of that. How after it goes through 6 people, it's so distorted. So anyway, but notice the best ones are in the Assyrio-Babylonian ones. One's the Epic of Gilgamesh. And we have to have some scholars that just can't help saying that maybe Moses got his idea of the flood from the Middle East people, the Babylonians and Assyrians. Oh, but we can tell when we go into this Epic of Gilgamesh, the shape of the boat that saved this person was 120 by 120 by 120. It was a cube. How is a cube going to do in rough seas? But the shape of the ark is a 6-to-1 length to width ratio, exactly what you expect with barges and ships. So the shape makes sense. Well, the Epic of Gilgamesh doesn't. So it's obvious that the biblical account is the real event. Okay, let's get into strata. Sedimentary rocks. Reason I didn't write sedimentary rocks here, it'd take too long. It's too big. So strata. Anyway, first of all, we got to graph the flood. Now, like every flood, and I forecast floods in the National Weather Service, by the way, you have a flooding stage. The water goes up, and then you have a retreating stage. Water goes down. And you can divide these up into phases, which we're not going to get into too much, but just think of those two stages. So this flooding stages is where you eroded a huge amount of rock and deposited it on the continents. And I've been able to estimate the thickness of this at the maximum flood. And then the top of it gets eroded as the continents are exposed above the floodwaters. Floodwaters are rushing off at high speeds, eroding. In fact, I made a calculation based on the amount of sediment in the continental shelf. The average erosion during the retreating stage of the flood was about 5,000 feet. Average. So the continents are scoured. And it was deposited where the current slowed up along the continental shelf. And that's why sometimes you have 15,000 feet of sediments along the continental shelf. So the flooding stage adds the sediments with the fossils in it. The flooding stage takes the top off and redeposits it along the edge of the continent called the continental shelf. So that's the big picture of the flood. 371 days long. And you can actually divide up the retreating stages in two phases. And I may or may not, I'll talk about phase 4, which is the wide currents, maybe 1,000 miles wide, sometimes moving at high speeds, eroding the continents. Then they narrow, channelize, as more mountains and plateaus stick up above the floodwaters. It's forcing the water to go around. And when it does that, it actually speeds up and channelizes and cuts canyons and valleys rapidly. And we'll get into that more. But okay, let's talk about the deposits of the sediments in the flooding stage. Grand Canyon is a great place to look at it. You have 4,000 feet of horizontal sedimentary rocks, and then you have a flat surface up there. And believe it or not, about 10,000 feet of sediments were on top of this surface right here, and it got eroded off during the retreating stage. I mean, we had monstrous, catastrophic processes during the flood. And they're easy to understand, too. We don't have to pick and choose and cherry pick the data. But anyway, there's a layer down near the bottom here. It's a sandstone layer. It's called the Tapete sandstone. It's a coarse-grained sandstone. You can see some of the grains of quartz in there, probably because it eroded granite, pulverized it, and granite being maybe 50% quartz. The quartz is very resistant, so that's what you have left. And this same sandstone you can find all over the United States. Sometimes you have to go down in a core and find it. It's on top of the upper crust of the continents. And so you can trace this same sandstone, given different names in different states. See, the geologists didn't know they were connected, and they got a little local area there and just named it and didn't realize, it was connected to the Grand Canyon. Okay. Up in my area, our area, in this area, it's called the Flathead Sandstone. And this is the Flathead Sandstone near Cody, Wyoming, the same coarse-grained sandstone on top of the upper crust, the upper granite crust of there. And you can keep tracing it. It covers half of North America. In fact, it goes up into Western Canadian Rockies and up into northeast Canada, and the Queen Elizabeth Islands and around in there. In other words, it's a sand about 100 to 300 feet thick with very few shale interbeds spread over half of North America on top of the upper crust of the continent. So I'm asking you, can uniformitarianism, which is what they believe, slow processes over millions of years, account for a sand spread over half of North America? No. This is probably the best example, but many other sedimentary bodies are traced long distances, hundreds of miles. Totally defies uniformitarianism, which would have small-scale sediments that change rapidly from sand to maybe conglomerate to clay. I mean, if you see the floods of a river along the side, you'll see that it's a mixture of sediment. They're layered, but the layers change rapidly horizontally and vertically. But about 200 feet of sand spread over the upper crust of half of North America, that's a flood signature. And most other formations, are large scale. So just in the sedimentary rocks, and it's the sedimentary rocks that they go and try to prove evolution to you, saying the lower sediments have the more primitive organisms, like a trilobite, whose eyes are much more complex than our own, by the way. And this is where they have the evolution. But the sedimentary rocks defy that and indicate that that it's the flood. Powerful evidence for Noah's flood. Then we can go back to Grand Canyon and notice that the sediments, they're different types: sand, stone, limestone, shale, which is a mixture of clay and silt, piled on top of each other. and they're hardened to rock. And to harden rock, you've got to have a lot of sediment above that presses it down, heats it, chemicals move in, and cement it. Like a sand is generally about 45% air. And you got to compress that and to make the stone. But anyway, let's look at this again. The layers in there, that represents, those horizontal layers represents 250 million years of time. All horizontal like that. But you know, erosion on a million-year time scale is rapid. You can erode all of North America down to sea level in only 10 million years at the present rate. Remember, the present rate. But as everything erodes, the rate changes. It slows a bit. But you can put a maximum, 50 million years. All the continents of the world will be down to sea level in only 50 million years as a max, 10 million as a minimum. That's fast. So at that rate, in 250 million years, where's all the evidence of erosion in these layers? Whether it's under the sea or on the continents, especially on the continents, it'll erode fast. So the erosion's not there. And we can demonstrate this. This is Grand Canyon. This pattern's the granite upper crust and the metamorphic rocks too. And here's 4 layers laid down flat on it, over 200 some odd miles. Again, not according to uniformitarianism. Uniform processes over millions of years. And as we continue on, say, just give it a 100, give it maybe 100,000 years, you'd have erosion in there. And then say you had another sedimentation event that deposited and that covered it. And so on and so forth. That's what the walls of Grand Canyon should look like. If it was just a deposit of 1 million years, just 1 million years laid down, that's what the walls should look like. You see evidence of erosion in all these sedimentary rocks. But you don't. You see generally even for that 200 some odd miles across the Grand Canyon. Sometimes the layers will actually thin or thicken a little. And like I said, the bottom layer you can trace over half of North America, the Tepete sandstone. And some geologists even admitted this is the south limb of the Grand Teton Mountains. There's Grand Teton right there poking up. And on where the upper crust came up 30,000 feet like that, going north-south. And it had sedimentary rocks on top, and they got eroded off, forming the Grand Tetons. And then on the sides, you have the sedimentary rocks. And I'm on the south part of them. And here are the same layers you see in Grand Canyon except one. And it's the bottom 2/3 of Grand Canyon. And they're even. And so 3 geologists who wrote a book about this said, well, the regularity and parallelism of the layers in well-exposed sections like I just showed you suggest that all these rocks were deposited in a single uninterrupted sequence. But do they believe it? However, the fossils and the regional distribution of the rocks, in other words, their theories or their hypotheses, show that this is not really the case. The incomplete nature of the stratigraphic record becomes apparent when the spans of time represented by each of the various formations are plotted on a numerical time scale. They plot it for about 180 million years, and they have huge gaps. One gap says 80 million years of missing time. No erosion in all that time. Makes no sense. And by the way, I'm not picking and choosing and cherry-picking data. This is a theme globally when you look at sedimentary rocks. The layers are horizontal. The erosion occurred after they are laid down, uplifted, they are tilted and broken up and channeled through it. But the layers themselves are horizontal and flat. Powerful evidence against uniformitarianism and for the flood. So let's go into fossils. Mike has a great distribution of fossils back there. I've been really impressed. You ought to see it if you haven't yet. But anyway, how do you form a fossil? Fossils are hardly ever occurring today, but we have hundreds of billions of them, probably in the trillions Most of them are shelled organisms, mollusks. But to form a fossil, you have to bury it quickly, or else it's going to rot, and even the shells and bones will decay with time. And it must be fossilized. In other words, you've got to send chemicals into the bones quickly before it decays. And that's a tall order today. And a lot of times you need thick sediments on top to cause this to happen. But the flood is a great mechanism because we piled up sediments. In fact, we have 5,000 more sediments that are piled on the continents that we don't have there. And that would help press down the sediments that are left to form layers quickly and fossils quickly. And so Ken Ham's famous quote makes a lot of sense. What do we expect in a flood? Billions of dead things buried in rock layers laid down by water all over the earth. That's exactly what we see. And so that's what fossils teach us. But we have a lot of great fossils out there. We have them in a lot of graveyards. In Montana here, we have a graveyard of 10,000 duck-billed dinosaurs, all of the same species, west of Shoto. 10,000 of them, and they're all mixed together in a layer that's 3 feet thick and about 2 miles perpendicular to the Continental Divide and about a half a mile wide. Estimated 10,000. And by the way, there's other ones over the earth that have 10,000 or more dinosaurs in a small area called a dinosaur graveyard. But this is an ammonite graveyard. Now, Mike has some great fossils of ammonites, the shoiled, curved, like a nautiloid. And then we have a lot of great fossils, fish-eating fish, like this one, fossilized rapidly. Didn't swallow his meal. And then we have this famous fossil, ichthyosaur. It's a marine extinct reptile, and it was fossilized at the point of giving birth. Oops, it disappeared on me. Oh, there it is. That's fossilized at the time of giving birth. And then mollusks. Those are shelled organisms, oysters, brachiopods, clams. 95% of fossils are mollusks. And I think Mike has some out there. You can see them, and they're all closed-shelled. Most mollusks are closed-shelled. Well, what's so significant about that? Well, the shell of a clam is held together by muscle. And when it dies, they decay rapidly, and the shell just opens up. And soon the shell just disappears because the shell itself has organic matter connecting it, too. So they don't last very long. But the fact that we have so many shelled organisms in the fossil record indicates a rapid flood. And these are fossilized, mostly fossilized, indicating rapid deposition and fossilization. So this is a sample of various shelled organisms from Oregon, from my friend, a friend in Oregon. Anyway, let's get into geomorphology. Remember, geomorphology is the shape of the earth. Geo means earth, morphology means shape, the shape of the earth. And we'll get to that slide again to refresh you. We've now jumped from the flooding stage, and that's where you put the sediments with the fossils on the continent. And then the retreating stage, the continents are coming up, and the oceans are going down, and the water's rushing off at high speed. Psalm 104, 6-9 tells you about that. And as the water rushes off, it erodes the top. Erodes. And thanks to a research project that John Reed, Peter Klevberg, who's from Great Falls, Montana, and I have been doing for a number of years, we have been able to estimate how much was eroded off. This is a simple box diagram to show this. This is the current continental surface. My cursor shows up out there, doesn't it? Doesn't. Oh. Okay. You can see the current continental surface, and we have the sediments that are left. We are right now trying to estimate what is left, and we're getting numbers on the average about 2,000 meters or...
Use this pointer.
Yeah, okay, thank you.
It's the top one.
Oh, yeah. There's the current continental surface. We're trying to estimate this state by state using sometimes thousands of wells. We're getting some really fantastic data that's not published yet. But we're able to determine how much was taken off. See, the peak of the flood was near 150 days, and during the recessional stage or retreating stage, we've determined based on the continental shelf about 1,900 meters average was eroded. Now, some places, I've calculated 4 different places, and I get numbers that big, like the Colorado Plateau, 130,000 square miles. The average erosion is 2,500 to 5,000 meters. That's up to about 17,000 feet of average erosion on the Colorado Plateau. So, we're getting numbers like that. And that has a powerful, says a lot about the flood. Okay, let's go into some of these features. As the water's running off, and at high speeds, it just shears the land, planes it flat, called a planation surface. Now, if it doesn't quite flatten it, makes it a little rolling, it's called an erosion surface. And here's a planation surface in the Bighorn Basin, one of my favorite areas. I've led about 4 or 5 trips there. In fact, Bruce was on one of, and his wife and friends were at one of my field trips to the Bighorn Basin. You can see more features of the flood and the post-flood ice age there, and even the pre-flood rocks than any other place in the world in the Bighorn Basin. Anyway, you can see sedimentary rocks dipping down like that to the west, and something just sheared this thing flat. And it's capped by about 15 feet of rounded rocks, rounded by the action of water. So all water did all this. And it's been dissected by late flood channelized erosion and then post-flood river erosion. So that's a planation surface. And such things are global. And in Montana, Peter Kleberg and I have documented there's various planation surfaces at different altitudes. About four levels down to the plains themselves, which is another planation surface. The top level is called the Cypress Hills there. It's about 80 miles long and about 15 miles wide. It's been dissected. After it was formed, it was dissected. You can see the white space in there. And this is a rose diagram indicating the currents came from the west-southwest. And that'll be important as I get into the quartzites. The second level is this Flaxville level. And it's been dissected a lot. See, these planation surfaces were once huge, but they were further dissected by further erosion, channelized erosion late in the flood, and then post-flood river erosion. And so here's the Cypress Hills right there. This is the northwest edge, flat as a pancake up there. And this is in the central part of the Cypress Hills. And this is the eastern part of the Cypress Hills, right in here. I wish they'd call it the Cypress Planation Surface, but it's a touristy area, so that wouldn't fly very well with the Canadians. And so, and when you drive up there, it is flat as a pancake. And when you drive to the edge, you see that's capped by 75 feet of rounded quartzite rocks cemented together. And I'll show you pictures when I get into that section. So Lester King, my favorite geomorphologist of a previous generation, he was a world traveler, said planation surfaces were once larger and over all the continents. There, you can even see them on the tops of the mountains in Antarctica, the mountains sticking up out of the ice. A planation of extraordinary smoothness developed over enormous areas on all the continents. A local event? A global event. From it, most of the world's scenery has subsequently been carved by renewed erosions. In other words, once you formed it, you broke it up. Sometimes some parts went up and some parts stayed down here. And you tilted it sometimes and then eroded it. So that's the way it is. And today, they're eroding. We don't see planation surfaces forming today. That's the catch. Uniformitarianism says present processes account for all the rocks. No present processes accounts for these huge planation surfaces. It defies their mechanism. But to us, it's powerful evidence for the flood runoff. And here's erosion. This is a planation surface east of the Little Rocky Mountains, north central Montana. And this stream coming out of the Little Rocky Mountains has been eroded this. It's so flat they have an airport they built on here to the left that you can't see. So, in summary, if we had slow erosion of this top of the continents, this is what we should see everywhere, especially where you have horizontally tilted sedimentary rocks, which are generally a combination of hard and soft layers. And the hard layers would end up as ridges if it was slow erosion over millions of years. Soft layers would erode a lot faster, and some of the sediments would end up in the valleys. But we commonly see this. Hard and soft rock layers sheared off the same angle. It takes a powerful current to do that, and leaving a capping of rounded boulders or cobbles on top. So in summary, planation surfaces not forming today, but being destroyed. Once much larger, and they're common as erosional remnants. They're worldwide. Difficult to explain, I'd say impossible to explain by slow processes over millions of years model. That's the secular model of geology. Powerful evidence for the global flood and seen everywhere. This evidence is not in a corner of the world. You can see it everywhere. And then the second feature in geomorphology is quartzite rocks spread hundreds of miles from their source. And this is similar to other mountain ranges of the world, which I've documented in a few other mountain ranges. But quartzite rocks are Montana rocks. We have billions of these rounded quartzite rocks, sometimes on the tops of mountains, sometimes piled thousands of feet thick in some ancient crack or valley, sometimes spread as a leg. You see these in a lot of different places. How many know what a quartzite is? Yeah, okay, we'll go into that. A quartzite is a metamorphic sandstone. It was started off with a sand, had a lot of sediment pressed down, chemicals, mainly silicon dioxide, come in from the sides and be absorbed and cemented into a sandstone. Therefore, it's a sandstone. But sandstone still has 20% air in it, would you believe? But a quartzite forms when it's heated up, usually under pressure, and it causes it to recrystallize and become kind of glassy, and it fills up those pores. So it's a very hard, tough rock. It's one of the hardest, it's probably the hardest rock in the Rocky Mountains that we have, and that's where it comes from. And this is on top of the gravelly mountains. They call it gravelly for some reason. There are quartzites rounded from the flood on the top of the gravelly mountain. In fact, on the top of 4 different mountain ranges in the Northwest states. I will probably get into that. I have a lot of slides, but you can see you can see the texture of it. It's kind of glassy. And notice that, look at the cracks on there. There's hundreds of semicircular cracks. There's a rock hammer for scale. They're called percussion marks. Percussion marks aren't forming today on any quartzite or at all. Anyway, we know generally where these quartzites form. In this area, western Montana, but especially Idaho. That's the general location, not in the eastern Rockies. It's a different type. They call it sometimes a hard sandstone, and some say it's a different type of quartzite, but this quartzite I'm talking about is a metamorphic quartzite, metaquartzite they call it. That's where it comes from. And we can trace those rocks on either side of that area, west and east. And so here's the big picture. Flood currents eroding huge amounts of sedimentary rock and eroding the quartzites, which are very layered. Sometimes they're 10, 20,000 feet thick in northwest Montana and Idaho. big, thick chunks. It's part of what's called the belt supergroup, if you've ever heard of the belt rocks. They're all around Missoula here. That's your hard rocks, or the belt rocks. Some of them are quartzites, but most of them are argillite, which is a metamorphic shale. The good quartzites are mainly to the west. But anyway, the land's coming up. It's on 104.8. The mountains rise, the valleys sink down. And then it splits the current, some continuing to go east, and then you have a backwash current going to the Pacific Ocean, like this. I don't think of these as channelized, but a lot of times at the beginning it was probably a continuous sheet that became channelized with time. And it's moving the quartzites and rounding them by water. Rounding. You practically only round rocks by water. Remember that. And then you move them way out into Canada. Yeah, they're found in central Saskatchewan, southwest Manitoba. And when we had our conference at Medora, we found them in Theodore Roosevelt National Park. They're all down in Wyoming, and lots going this way. There's dozens of these locations. So here's where they're located from that deposit going into Wyoming. The big, thick areas are huge masses of quartzite. And these huge masses you see here, just south of the Montana high border, that's 15,000 feet of rounded rocks and boulders. You can drive up on it, which I've done. And by seismic methods, it's 15,000 feet thick, and the top has been eroded. And here at east of Jackson, Wyoming, the Big Hole Valley, up to Yellowstone Park, you have another big mass. And the state geologist of Wyoming said it was about 11,000 feet thick. But we know the top, he said 80% of it has been eroded. In other words, the top has been eroded. And we'll see evidence of the erosion of those two masses. But we find them a lot of other areas clear into the Powder River Basin over in this area, which I haven't seen yet. But this is the Bighorn Basin right here, and I've seen them quite a few places in there. And I discover new ones all the time. Where I'm from Bozeman, west of Bozeman, there's 15 feet of quartzite capping a planation surface south of Three Forks. It's just west of the Madison River and about 10 miles south of Three Forks. Fantastic site. I've taken people up there, but the last time I was there, they had the gate closed. Were you on that trip? Okay. Anyway, let's look at some. Here's the Teton Mountains. It's kind of a leg in the Teton Mountains. And from mainly after this was deposited, maybe 25,000 feet, the top 10,000 feet got eroded. And Brent Carter, who's a creation geologist from Boise, and I took a hike up there, 3-day hike up to the top of the Teton Mountains. And here we are, about over 10,000 feet, and here's some of the rounded quartzites on the top of the Teton Mountains right there. And here's the largest one we saw, about that big. And when you look at some of them, here's your percussion marks. See these semicircular cracks? But some of these marks, right, you can't, oh yeah. There's beautiful percussion marks on top of the Teton Mountains. These are not percussion marks, they're pressure solution marks, where you have thick piles of quartzite, and where one quartzite is laying on another, the pressure of all that material above kind of recrystallizes the edge and kind of forms it's called a pressure solution. By pressure, it kind of dissolves it and recrystallizes it. And then we can go west of the Rocky Mountains, and all these green areas are where you find quartzites, and most of them are on the highest terrains in this area. These in here, okay, that's right, my cursor doesn't work. This is along the Horse Heaven Hills, up to 4,000 feet above the Columbia River, all across on the ridges around Yakima, and all through this Columbia Gorge. You even find them out along the Pacific Ocean. Here's the Wallowa Mountains. The tops of the Wallowa Mountains are just covered by quartzite rocks. In fact, There's so much quartzite up there that there's fines in there too, in between the quartzites. And there's gold in the fines. And so they had a placer gold mine on the top of the Wallowa Mountains, above 8,000 feet, until it became a wilderness area and they had to close down the mine. Can you imagine that, a placer mine where they send water to a sluice box? And anyway, we took a hike up there, and here's a quartzite location on the Wallowa Mountains. And this is the largest boulder we found. And here's the finds where you find the gold. You find gold in all these places. We estimated the weight of that 440 pounds. I would have liked to. We had horses up there. They couldn't get up there, but we had horses with us. If we could have got it down 400 more feet, rolled it down somehow, the horses, I don't know if they can carry that back, but I'd sure love to have that in my rock garden. Anyway, that's on top of the Wallowa Mountains. And on top of the Cypress Hills, so we'll get back to that, it's covered by 75 feet of rounded rocks. You're looking down to the north in Canada, 1,000 feet lower to the next lowest planation surface. And when you get up close, that's what it looks like. Rounded quartzite cemented together. From Canada, from Idaho. Another close up. And they have percussion marks. These are the largest percussion marks I've ever seen on a quartzite. They're not forming today. This is a very hard rock. Talks about tremendous turbulence. Here's the big picture. Currents coming off the Rocky Mountains, and the large rocks are being scraped along the bottom, eroding. A huge amount of erosion occurred on the plains, eroding it down. The small to medium rocks get taken up into the current, come crashing down, forming the percussion marks. And by civil engineering, open channel flow equations, we got minimum depths and current speeds. These are minimums. The 6-inch wide bullet-shaped rock, that wide and that long, estimate 65 miles per hour. This is about 3 times the fastest flash floods on Earth. They go down steep slopes. And this is minimum current depths coming off the Rocky Mountains. So in summary, quartzites are spread 800 miles east from their source, which is on the other side of the Continental Divide, I might add. And they're spread 400 miles west of the Pacific Ocean. Percussion marks indicate torrential flow, powerful evidence for flood runoff. Powerful evidence. I will quickly go through the last one, water gaps. Water gap is a gorge through a mountain range or ridge. My favorite one is near Cody, Wyoming. I'm looking west towards Yellowstone that you don't see there. Here's the Shoshone Water Gap. The gap is 2,500 feet deep, cut through hard granite. The river coming out of Yellowstone could have gone around like that, but it didn't. It cut right through the mountains in a water gap. There's thousands of water gaps across the earth. When you get on the other side of that water gap, there's the water gap there, and it's so low that when the sediments were higher, the river should have went out that way, but it kept going east, just plowing right through there without stopping. There are thousands of those water gaps across the earth. But I'm just going to quickly tell you how we believe they formed in the flood. By the way, secular scientists have a lot of difficulty explaining these things. They try. Anyway, you have wide currents moving across a ridge. The ridge might be coming up. The waters are draining. Remember the retreating stage. And then there's low areas on ridges, so the currents will tend to speed up. And as it's exposed, it's channelized, and it's cutting gorges rapidly. It has to speed up. And erosion is to approximately the 4th power of the velocity. Increase the velocity twice, the erosion rate goes up 16 times. And as time goes on, the ridge comes up and the waters are sinking, it's channelized even more. And you have 2 channels here in this illustration, but this gives up over here. Well, the other cuts all the way down to the level of where the river can pass right through it. But this, it doesn't. It leaves it high and dry. It's called a wind gap because only wind is going through that. So the question is, why can't mainstream geologists see the evidence for the flood? I mean, it's all over. Globally, thousands of these things in geomorphology. Well, it's a psychological phenomenon that occurs to everybody. It's a human tendency, and I found this in the book called The Promise of Sleep. I was a shift worker, and I had 40 years of being like a zombie. So I tried to do the shift work better, and we did. We found out. But anyway, I came to this quote from this sleep researcher. He's one of the discoverers of REM sleep, by the way, William Dement of Stanford. He says, even when they are looking, people usually see only what they expect to find, and they do not see what they assume, for whatever reason, could not exist. See, geologists today are stuck in uniformitarianism in their mind, and everywhere they see the walls of Grand Canyon, slow processes over millions of years, it's glued. It's locked in concrete. It's taught in the culture. And anything about catastrophism like the flood is rejected. So that's why they can't see it. Anyway, we have answers. And much misinformation in the culture. We need to educate ourselves, our children, grandchildren, on this issue. It's greatly affected the church, as other speakers have also mentioned. And we have reasons, and that's what this conference is all about. And to learn more about it, you can see how Noah's flood shaped our earth. In this publication with Dr. John Reed, he's a PhD geologist. And we talk about the pre-flood world first. We're doing this chronologically. Pre-flood, what's the pre-flood world like? Well, we have some clues from geology and the fossils, believe it or not, and as well as the Bible. And then the early flood, which I talked about earlier in this talk. And then late in the flood, the runoff. And then what happened after the flood, the ice age, and so forth. Anyway, you can get that resource because you're only going to remember 5% of this after you leave in a week. And for those that don't know much about geology, Rob Carter and myself wrote this resource, Biblical Geology 101. It teaches you some basic geology. And what's just some basic geology? You could see it for yourself. You could see these things for yourself. It's not hidden in a corner. And I've written 5 children's books, and of course, geology. This is a fun book for young people, grades 5 and above. Exploring Geology with Mr. Hibb. He's an intelligent grasshopper that we have cartoons in it. It's a fun read. We also have one on dinosaurs. And we're working on one on the Ice Age right now. And these time questions. Hopefully this is a layman-friendly book. I wrote it hopefully for people with no science background. The Deep Time Deception. Examining the case for millions of years. So we go into a lot of different things. And finally, you can get this talk on DVD, The Receding Floodwaters, where I show you these features out, mostly in Montana and Wyoming, by the way, the runoff, and show you the features out in the field. It's just not a talking head for about, I think it's 90 to 100 minutes, and I think that is all, and I want to leave you with this quote and then some websites. Your faith should not rest on the wisdom of men. That's what evolution, millions of years, and uniformitarianism are all about. But on the power of God. God has power to do this stuff. And any miracle. Anyway, here's those websites. I recommend creation.com. Over 12,000 articles for all ages, all scientific abilities, professors to young people. Creation.com. It's easy to remember. Anyway, thank you.